Good evening everyone and welcome to another edition of Pico Academy. Streaming to you live from our workshop live at Pico HQ here in the UK. So welcome. Particularly obviously welcome to customers of two of our distributors, Garage Lube down there in South Africa. Welcome to you, Kai, and then up in the Northern Hemisphere, Autotech based up in Iceland, one of our newer distributors. So thanks for coming along. Hope you enjoy what you see. Before we start, I just want to pause a moment. Why do we do this as a business? Why do we try and learn? And of course we have to learn because we become better. But a lot of, particularly when we're looking at oscilloscope diagnostics, about repetition and building up your understanding. So I quite like this as a thing. So education is what survives when what has been learned has been forgotten. So actually by practically doing things, seeing us do things, hopefully, you'll gain an understanding of practically how you use Picoscope every day. So this is what we're working towards very roughly. So we'll obviously start at 5 o'clock UK time. So in about an hour and a quarter, we'll have a break for 15 minutes, just give you a chance to go and get yourself a drink, stretch your legs, and then we'll start exactly sort of 6:30 then, so it'll be 6:30 our time. And we should be finished by 7:15 our time, so about 2.25 hours time, and there'll be Q&A. But as we go along, if you fire any questions you've got into the chat box, we'll answer those as we go. And what we tend to do at the end, we do a summary, so I'll pull up all of those comments and questions. So if we have missed anything tonight, we'll always come back through our distributors and I can hear myself on another screen. That's really painful. Okay. Yeah, so what we do distributors. That was on my phone, Ben, my bad. Yeah, so we'll come back through distributors and we'll answer any questions that came. We'll give you examples of where to go and find further information or waveforms, anything that we can share that'll help you with that. Okay, so let's make a start. So first of all, first question should be, what is Picoscope? Well, very simply, it's a diagnostic oscilloscope, so we can read any component on a vehicle. So we'd say anything with a wire, we can read. We pass that through the oscilloscope, so that is of course Picoscope, and we turn those signals into a waveform. And kind of looking forward, we could also look at pressure and now NVH, so noise, vibration, harshness signal. So anything with a signal, we can turn that into a waveform, which effectively gives you, the technician, a way of viewing it and understanding, so something you can see. But what do we see? Well, we see the waveform, and if you're not sure, waveform is very simply voltage plotted against time. So that's our multimeter signal, but plotted 400 million times a second. So there we're going to talk about the sample rates. The sample rate is 400 million samples a second. Why is that important? Well, you'll see as we start to run through the evening. So like I said, 3 major types of signal we can look. Electronics is where you're going to start, and obviously most of what we're going to focus on tonight is going to be around electrical systems with a vehicle, so things like sensors, actuators, right the way up through communication networks. And we are going to touch on a nice little EV case study towards the end of the evening. Pressure, so that's looking at pressure against time, and we do come to that in the second half. And then finally NVH, so that's our noise, vibration and harshness. And that was something from our last sessions. So when we were running these in autumn last year, we had a lot of requests for NVH introduction. So we are doing that as the final bit of our presentation this evening. Okay, so let's have a quick look at an example. And this is one of our top 10 tests. Animations that we have. So just to see what's going on. So we're going to look at relative compression. So here we've got obviously engine working. So we can look at relative compression with just using our 2000 amp clamp, so it's just plugged into one of the channels on the oscilloscope. And we need this test cranking only, so we don't want the vehicle to start. So in this case, we've removed the fuse, stop the engine starting, so we're just cranking. And what we would hope to see, or would expect to see, is a nice clear sawtooth pattern. If you notice there, we've got one of our sawteeth missing, so we've got a problem with compression. This would indicate there's a problem with compression on one cylinder. So then we need an ignition event. In this place, we're using the coil and plug probe, and that allows us to understand which of the cylinders we've got an issue in. So that's a very quick example. We're going to come back and keep doing this again and again in a little bit more repetition as we go through the evening. So how does it help? Well, by connecting to the actual component. So bear in mind we're breaking into the actual component. We can see what's going on in real time. Yeah, so we've got no filters for a vehicle ECUs. And like I said, that detail capture 400 million samples a second. And with this format, we can measure, and a bit of knowledge, of course, most importantly, understand what's going on. So just a very quick note about live data versus picoscope or an oscilloscope pattern. We quite often get told that, well, I don't need an oscilloscope because I've already got live data on my serial tool. They are different. The waveform, if you want to call it that, what we see on live data, so yeah, it looks like a graph in the same way, but you're not going to get the same detail, and it often is a filtered signal through an ECU. So the top one there is our live data. So we're seeing both tracks of that component operating, but then if we look at the below, and you can see how much more detail we see with picoscopes. You've got both tracks, but we can see them and how they operate together. So it is quite different, and of course we are breaking directly in to that sensor in this case. Okay, so where to start? So you would go onto our website, so it's www.picoauto.com. Just be careful, we do have another part of our business which is Pico Tech. So if you put Picoscope into Google or another search engine, just be careful to make sure you go on picoauto.com. And then you can download your software. So you can download your software for free. You don't need to have purchased Picoscope to get hold of the software and to start working with it. And it's free to download, so we make that very clear. You don't have to subscribe. There are no monthly fees, so you can download it and start using it and working it in demo mode. So just a very quick overview what we're going to see, and then I'm going to take you into the software and take you through a tour. So this is our latest generation. So Picoscope 7 is currently still beta, but we'll be going to a full stable version early summer. Should be June, July now. So if you are new to Pico, certainly download the beta version and start using this. It's more or less complete. It's pretty stable now. There aren't many bugs left to iron out. So start to use it, start to understand it. And one of the things you'll see is this much simplified, clearer menu. And then what you can do is you become a more advanced user, you bring the more advanced features into your menu. So I think what the easiest thing for me to do now, I'm going to switch screens and I'm going to take you through a tour of the new Picoscope 7 software. So let me just flip screens. Okay, let's have a look at Picoscope 7. This is the automotive version. Currently we're running this on beta. And as I said, you can download this from the website, and we're really recommending that everybody, even though this is a beta, particularly if you're starting from new, start getting used to working on Picoscope 7 now. So I've not got scope connected, so actually you could download the software tonight and run it in demo mode, as I'm going to do now. So yeah, just open it up by clicking the icon that will appear on your desktop. So just have to highlight that and go OK. So it's going to give me a demo signal to work with actually. One of the things that you'll notice if you're not familiar with Picoscope 7 is that straight away you get this guided test menu that comes up, which gives us all of our guided tests, for operating and testing all your major components. And look, now we even have an electric vehicle selection. Don't panic, it's support material, so you can go in there and kind of further training links, case studies, etc. to read up on. We're just going to close that for a moment. We'll come back there in a little bit later. I've got 2 demo signals running. So we've got ignition. And as you can see, it's quite easy just to move signals around so you can see them together. So we've got the scope running at the moment. We'll just turn that off. So back to our original. Remember, we talked about voltage against time. So this is our voltage here, and then our time base across the bottom. So we've got, as you can see, 10 millisecond divisions between areas. So if I change it to 50 millisecond divisions, you'll notice what happens when I start the scope again. The signal's not changed. And we'll just press that, then we get more space on the screen. The signal hasn't actually changed. What's happened is we've got more time showing on the screen. So we've got those 50 milliseconds between each of the grid lines. So just stop that a moment. And then controlling our voltage scale, if you like, is done here. So we've got the 4 channels of our scope, A, B, C and D. We'll just concentrate on channel A at the minute. So we can change again, we can change the scaling like we could on the voltage. So at the moment it's plus or minus 100 volts. We can bring that right down, and again, it really depends what you're trying to measure. So, you know, you get help there from the guided tests, but we're just using standard test leads. So here it is, a ×1 lead. We can pick, so one of the things that you're going to get used to watching tonight is when we're working on Pico 7, you still have the option to pick a probe. So these are just standard BNC probes. So if you weren't lucky enough to have a BNC plus probe, then you are just going to use a standard BNC probe. So you would pick it from the menu here. So for instance, if I wanted to choose a current clamp, I would click here on our 2060 amp clamp, call unplug probe down here, right the way down to WPS. So they're all there. And then we've got various display options also. So, you know, again, just by opening and closing, you can start to work your way around there. Currently got the scope stopped. One thing you should be aware of, you know, we're not just taking a picture. It is like a video. So it's a bit like how Sky Plus works. When you click on here, you can go back through time. So we've got 64 frames of data. Why is that important? Well, we want to see, generally with electronic items, they do the same thing again and again. They're designed to do that. They're designed to do that in repetition. So by being able to go back through, effectively scrolling back through time is something Frank Massey calls a time machine. We're able to check the same things happening again and again, repeating, like I said. So we've got our rulers that we bring in from here. Yeah, and then now, for those of you who are familiar with Pico 6, Pico 7, our zoom is actually in the body of the software. So when I zoom in, yeah, and that allows me to zoom in and make sure that my measurement between 2 events is very, very accurate. And I can just, and then when I come back into my zoom menu here, I can then zoom in. So this is the second. So again, I wasn't very accurate. So it just allows me, by using zoom and rulers together, it allows me to be really, really accurate with our measurements. And one really cute feature of the rulers is you've got this padlock here. So if you're not familiar, so point 1 is here, and then point 1 is here. So it's about 60 milliseconds between the 2 events. There it shows us there. And I can come out now of zoom. And what this means is, look, in our waveform 47, if I now go through to waveform 60, then I can move this along. And again, by using my zoom, which has neatly hidden itself away up there, I can zoom in and zoom in again. Just make sure that I've got that in the right place. And I come out, and then I can zoom in there. And effectively what you would see, if something had moved, if you've got some kind of timing issue, there would be a big gap there. There's a slight change, but nothing to be overly concerned about. Again, with most of these items, you can pull in and out of the menus. So I'm just going to close that. I'll close rulers and I'll close zoom. So we go back to the new point. Really nice feature within Pico 7 is you can really set up the menu to be exactly how you want. So when I go in here for more, you'll see there are quite a lot of items that I don't have in my menu. So if I want, this is quite useful to have the open. I mean, that, of course, they live up here, but you can also put them in the sidebar. Yeah. So let's just click off and on, and you see how things like math channels, you might find when you're new to Pico, you don't use math channels very often, so you can just hide them because you don't need them. Again, if I come back in here, there we go. So we've just got a really, really useful feature, particularly if you're working on a small screen. We tend to work on really large screens here in the workshop, as you'll see in this evening. But being able to, if you're working on a laptop or a smaller screen, being able to just use the full screen mode, just to zoom in and analyze is really, really useful. Of course, you've only got a limited amount of menus, but if you've already opened something, it will still be available when you're in zoom mode. Just gives you, you know, the full screen to use all the architecture. And then F11, I'll just pull out a zoom just to close down. There we go. So you can zoom in and out. And one final little point I'm just going to do is a reference waveform. So reference waveform means that, so at the moment I've got 2 channels of data available. So if I go A, what it will do, it will give me a duplicate of a signal. So you can call that whatever you want. So I'll call it A2. I'm going to put that as green because I believe that's a good known waveform. And go OK. Just save that. That's done. So now what you'll see on the screen is that waveform, sorry, to move the whole thing, so that injector is now visible and held on the screen. So then you'd move over to injector number 2 and capture the one, so you could look at them side by side. So yeah, so they're the basics of the menu. Of course, there's a huge amount more in here, but that would kind of get you going. So like I said, download the software, start to familiarise yourself with the major parts, you know, of working with the software. So using, being able to alter your time base, using rulers, using zoom together will allow you to analyse data really, really nicely. Start to work your way around, you know, our voltage scale. So the way we can connect components, as you'll see with BNC+, it really is much simpler. It's automatic. So yeah, you know, start to use it. Even if you haven't got a Picoscope, you can start to work your way around it. And then back, if you remember right at the beginning, I did mention our guided test. Really, really valuable resource. So we'll just go and have a look at one of these. So we're going to start this evening actually when we shortly start working on vehicle. We're going to look at a camshaft position sensor on the A2. And I'll just show you what's in here. It's a Hall effect sensor. So what we have here, and I've selected the Hall effect. So we can either just load the settings, which means it will just set the scope up for you, or we can also open a guide. It will also set the scope, but what it means is it gives you nice catalogue of information to start building up your library of understanding, work with Pico. So all of our guided tests, there's over 150 in here, gives you a really, really nice schematic diagram of how you make that connection. Remember, we're always earthing each channel, and that shows you how you perform it. We give you an example waveform, so what we'll expect to see the waveform to look like. Be interesting to see if when Phil does the test in the workshop, how that pans out. Then we've got waveform notes, so why the waveform's the shape that it is, why it's doing what it's doing. In this case, we've got a nice square edge waveform. Then it points you to the waveform library, so of course really, really valuable. We're going to look at cam and crank measurements a short while later on, and having a good known waveform from the vehicle you're working on can be absolutely key to the right diagnostics. So, you know, having a link in there to the waveform library, really, really important. Yeah, one thing to say about the waveform library is actually at the moment in beta we don't have the waveform library operational. We're only literally a few weeks away from that. We have started to see our end what the waveform library is going to look like and how it's going to work. So we're really, really close to that. So again, you know, start just working with Pico 7, so you won't have to relearn literally in a few weeks when we go to a stable version. And then finally, some really excellent, got what we call further guided, really just a really huge library of information about how components operate, how they work, and a really nice background for you to, you know, build up your own understanding of components. And sorry, Alan, I forget this. We've also now got diagnostic trouble code, so you can search. If you've got a DTC from your scan tool, you can search in here, and it'll kind of link you to the correct test. So I'm just going to minimise that. And what you'll have noticed, because I've opened that guided test, and again you can move that up out of the way, it set the scope up for me. So my time base, if you see, is moved from 20 millisecond divisions across the bottom, and then our voltage scale, look, because it's a 5-volt sensor on the whole, it's taking our voltage to plus or minus 10 volts. So I think that's it for software now. We're going to obviously dip back in and out of software through the evening, but hopefully it'll give you a nice little overview of working with Picoscope. Okay, let's go back and we're going to start to look at some hardware. Okay, well hopefully that's given you a nice starting understanding of Picoscope if you're not already familiar with it. It is a lot to take in if you're a new user, so don't worry too much. What I should say is that we do leave these videos up, so this link will continue to work, so you can go back and watch any part of it on catch up. You know, particularly useful if you manage to get a scope and you want to try some of the tests we're going to do on vehicle. It's a really nice reference for you. Okay, so final piece on software, and then we're going to start to look at the hardware. So if you're not aware, Picoscope, we create kits for more vehicle manufacturers than any other oscilloscope manufacturer. We currently supply oscilloscopes to over 30 vehicle manufacturers, including the likes of Tesla and Future Technologies, as well as, you know, obviously all of the well-known vehicle brands. Why is that important to you in the aftermarket? Well, the reality is every bit of work we do in terms of new technology, particularly, you know, as the industry changes as fast as it is at the moment, all of those changes appear in the aftermarket software. So we might do some work. I mean, I've just given you there a screenshot from the Volvo software. Now we might do work with Volvo looking at future technologies, but all of the advancements in software always make it onto the automotive external release. The only difference actually within the vehicle manufacturers would be they maybe put their own waveforms, so waveforms from their own vehicles by make, by model, will be in there, but apart from that, everything will work exactly the same. So that's really a little bit about the work that we do with vehicle manufacturers, and that means that, you know, purchasing Picoscope today in the aftermarket, that product will become better because the software will continually evolve. And certainly what we've seen with the jump from Picoscope 6 to Picoscope 7 has shown a big step forward in terms of oscilloscope diagnostic software. Okay, so let's start to look at the hardware, and I'm going to take you through the basics here, and then Phil's going to open a kit up. So we start with standard test lead, so we just plug that in at the front. So what you'll see now with the new scope, we've got our BNC Plus connection. So we've got those extra 6 pins of data that we get. Then on the end of our test lead, we have a range of clips and adapters. Most popular would be what I'm showing you there is backpinning probe. We have various breakout leads right the way around to this breakout lead set. So that's a set of 12 breakout leads, and most of these you're going to see us work on vehicle this evening. Then we have current clamps, so one of the big advancements of the BNC Plus powered probes is the fact we don't now need batteries in the current clamp, so no more kind of working on parasitic drain and a battery running out halfway through a capture or a test. We are now powered all through the scope. Then corner plug probe, so we're going to have a look at coil packs tonight, capturing data with that. Then we've got our oscilloscope probes, so that's our ×10 probe. So anybody who's familiar with the old scope, we used to have an attenuator that you'd fit in line with the scope, because we've now got the BNC Plus, it's actually now its own probe. So it's a much better quality signal. Then we've got pressure transducers and round to MVH, and we're going to come back to them in a little bit more detail through the evening. So I think the best thing we can do is pass you over to Phil, stood patiently behind me, other side, and he's going to open the box of a standard kit and take you through the main hardware of the Pico 4425A oscilloscope.
Hi, today we're going to do the unboxing of the 4425A standard automotive kit. So, what comes in the kit? Well, effectively we have a 4-channel BNC Plus scope with our 4 connectors on, housed in a nice rubber boot, and of course here we have the hanging bracket and the USB 3 connector. So we have a selection of goodies in here. They all come with the kit in either red or black. So we have all of our accessories, our battery clamps, 4mm adapters, flexible backpinning probes, multimeter probes. All of those things are included in the kit. With everything, we have the safety guide with all the information in. So, 4 standard coloured leads matching the colour of the scope. So these come in 3-metre lengths. This is the new lead that's in the kit, the TA499. This actually replaces the attenuated lead that you used to get before. So where we're doing primary ignition or high voltage, we use this. Not forgetting that we also use it on FlexRay. Here we have our standard ignition pickup clamp with the earth clamp. USB 3 cable. Coil and plug probe. So again, nice new connections on the coil and plug probe where we actually have BNC Plus. Within the pile of adapters that we have here, we have 2 fuse extension leads, which are here, and an earthing strap which we actually connect to the coil pack when we're doing the diagnostics. We also have here 2 fuse extensions. So we put this into the fuse box, put the fuse into there, and put our current clamp round here. So, S-hook for hanging on the scope. So we can actually look at the S-hook. We can connect it on to the case. And we then get 2 current clamps. The 2000 amp clamp, nice big jaw. Remember, because this is BNC Plus, we don't actually have to require a battery. We just put it around the lead. And then here we have the 2060 amps clamp. Again, BN Plus. So again, we do not require batteries on any of our current clamps as we are now. The other little thing that we have is our back pinning probes, which are renowned for being so good, and that when we actually break our ends off, we can replace the ends and put new needles in. So this is the contents of all of our kit, and please remember that you can also order this kit with foam inlays on the website, so if you want to put them in a toolbox, you can. Please look at the website, which is picoauto.com, for any other details that you may need.
Great, thanks Phil. So that was our standard kit, and obviously there's a whole range of kits, so obviously the best place to look at that is online on our website. But we have kits ranging from about €800, so that's our 2-channel starter kit, and then right the way through, so that's just a picture of everything that comes in our standard kit, and then that's our master kit. And one other thing to make a point about when you are choosing the kit, remember that all of the kits are available in foam trays. So as you'll see when we start to work live on a vehicle, Phil's got everything set up in a nice tool trolley. So like a diagnostic workstation, he's got the boom hanging up. So at the end of the day, everything's put away and safe, but actually when it's in use, it's hanging to make capture and connection as simple as possible. So yeah, so a whole range of kits for budgets and depending on what you're trying to do. But just to give you an idea, we've got about 150 guided tests, as I mentioned earlier. So if you take the 2-channel starter kit, you can do about 50 of those tests. Running through to the 4-channel standard kit, you're nearly 100 of those guided tests. And obviously when you're in the master kit, you can do more or less all of those guided tests. So it just gives you an idea. It's not just about what's in the kit, but it's about what you can do with the set of components, the set of accessories in that kit. Okay, and we've kind of covered BNC, but it is a whole new user experience. It really is much easier to connect than a standard BNC. It's got a really nice click and a nice attached, and everything's just much more simple. So the probe, you plug in the probe and the scope knows, and then the software knows how to set the scope up. If you open a guided test, the scope shows you what probes are needed to be attached. So it points you in the right direction, and you'll see it as we start to work live on a vehicle. When anything goes wrong, we've got something called probe mismatch. So if you do plug in the wrong probe for the capture you're trying to create, it just pushes you back on track. Okay, so that's kind of basic overview, hardware, software. Now we're going to start working live on vehicles in the workshop, which I'm sure most of you will find much more interesting than that. So just a note about how we work on vehicles. Everything we do, we try and break the test down into 3 simple steps. So that's connect, run, and then read. So we're connecting, how we connect to the component and what we use. Then running the test, so how the vehicle needs to be to capture our data, to get our waveform. And then of course the most important thing is, once we've got the waveform, is how we read it and understand it. That's where the real skill is, and we're going to point you in the direction of working through these waveforms tonight. And one final point about capturing data, we only read electrical signals with Picoscope, and we don't apply any voltage into the circuit, so it's perfectly safe to use. But like we'd say to all new users, use the guided tests. They're there to help you make sure you do things in the right order of understanding. Okay. So let's just have another, so this is another one of our animations. And this is an ABS wheel speed sensor. I'm just showing you, so we connect with Pico using a backpinning probe, and then we're capturing our data, or our technician's capturing data on a road test. So when he comes back, if you don't know what that waveform should look like, well, where do you start? Well, we'd always start with our guided test. So there we've got obviously how we made the connection. What should the waveform look like? And then there's a real nice library of information, how that component operates, what to look out for when things go wrong. But most importantly, often go to our waveform library, search by the vehicle make, by model, by engine code from the vehicle you're working on. And with a bit of luck, you'll find the same sensor. So yeah, our technician here finds a known waveform, and again we can use the functions within the software to zoom in, to look at more detail. Where else can he look? Well, we'd always recommend investing in good technical data as a technician. So again, he's here searching for if there's a known problem, so in this case a service bulletin, and indeed this is a known fault within that sensor. So we've got the waveform, what happens when it goes wrong. So great, so we've now verified what the problem is. So now we're going to replace the component. So a component's replaced. What's the final thing we should do as Picoscope technicians? We're going to verify the fix. So we'd reconnect to the component, another road test, and now we're checking that the waveform is absolutely as it should be. So if you saw before, we could see that missing tooth on there, and we verified the fault. So now the waveform's back to how we'd expect it to see. So that shows you, connect, running, capturing our waveform, but most importantly, reading, using all the available data and information to make a good diagnosis based on facts. Okay, so we're going to go to our first test, which is multimeter versus Picoscope. And when we do this very simply, because I'm sure most of you, even if you don't have an oscilloscope, will be using multimeters to figure out if a component is operational. So you'll be familiar with multimeter use. So we're going to connect in exactly the same way. In this case, we're going to look at a camshaft sensor. Phil's going to be using a backpinning probe. And we tend to do camshaft sensor because this is a really nice one to practice on. It tends to be on the top of the engine. You get a nice clear signal. And in terms of how we operate to capture the test, we want the engine running, so we just want the engine on idle to capture our data. Now with our multimeter, we're going to see something like this. So we're going to see a fairly static figure. In this case, it's 12.16 volts. So we assume this is a 12 volt sensor, be fairly typical. Well, actually, when we now move on to the Picoscope, so the connection's the same. As you'll see, Phil will just piggyback the multimeter into the back of the test lead. But what we see, and Phil's going to show you this on his screen so it'll be much clearer, actually this is a 15 volt sensor. So it's quite unusual actually, but we get these nice square edged waveforms. So we get this square edge, so 0 to 15 volts. Why did the multimeter say only 12 volts? Well, actually, it can only average. So if you see, we've got 15 volts, then down to 0 for a while, then 15. So it's actually taken the average measurement through here because it can't see the detail of those 400 million samples a second that we can with Picoscope. So that's a quick overview of the test. I'm going to pass you over to Phil now, and he's going to talk you through multimeter versus Picoscope. Over to you, Phil.
Thanks, John, for that. We're going to go through the connection and just show you what we're going to do, how we connect to the car, what we're going to do. So first of all, let's get our test lead. BNC Plus. We're actually going to plug this onto the scope. So we've got our 4 little connectors on there. So we're going to hold the scope, put that on top of there. And now we're just going to go over and show you connection wise. So what we've got here is the back pinning probe is into the centre, and we've got our test lead plugged in. Our voltmeter is in the back, and then we've got our earth strap here with our voltmeter plugged in as well. So we're going to use both voltmeter and the scope. So now we're going to pick our software. We appreciate that actually for some users that are perhaps more advanced users, you're going to use the software, not use the guided test. You can always set the channel up and the timescale manually, but we're going to show you how to do it in the guided test. Right, so we're going to pick sensors. We're then going to go cam position sensor, and you will see that we've got 3 sensors here: inductive, AC excited and Hall effect. We're normally going to see, on a lot of vehicles, we're going to see Hall effect. So this is what we're going to see most of the time. Inductive, normally you'll see on crankshaft sensors and other things, but you'll soon get to learn what they look like. And again, as John showed you and talked about earlier, this is where the waveform library is so good that you can go back and look and see before you do the test what sort of signal you might get, so we can set the channel up. So we're going to look at my screen. So we're going to go Hall effect. And we're now going to go, do we want to load the setting file or do we want to do the guided test? So we're actually going to do the guided test. Again, here we have the screen. So we have exactly our connection. So we've got our test lead plugged into our sensor using the back pinning probe, and we've earthed out the unit. So now we're going to go down the page, and this is giving you an example of what we should see on the screen. Then we have further down information about the sensors and what's happening, reference to the waveform library, and then a guide to how the sensor works and what the things are going to be related to what we have. But also we have things like fault codes that actually are associated with this. So from there, we're going to close the screen, and here we've got our voltage and our time scale. So I'm now going to push the start button. John is going to start the vehicle up. Okay, so what we're now going to see, we're going to see that actually the scope has set itself up to 50 volts here. So, yep, it's set itself up. What I'm going to do now is stop the software, and I'm just going to drag down the measuring ruler just to show you what we're actually seeing, and then we'll look at the screen of what John's got on the voltmeter and compare. So again, 15.35 volts, and on the voltmeter 13 volts. So this is where we're seeing the difference between the voltmeter and the scope. But also when we look at the software, we have lots of things that we can do. So we can now zoom in to any part of this signal, and we're going to look. This is the repetitive opening and closing and the voltage changing as we're looking, and we're looking for the characteristics that this is continuous, which we can see. Now you can also see here, if I zoom into this part, we've got interference, and we'll talk about that interference a bit later. because actually this is something else we can look at and see. Don't disregard any interference that you may get from a signal, because that could be something else that we're picking up just because of the environment of the engine. We've got an engine, as you can see, with lots of wires on, and we will pick up signals from other sensors sometimes. So very important. But just to show you actually how to look at the signal, how to use the measuring rulers, and then what we've got on here, not forgetting vehicle details. So we actually save the decals of the vehicle and the waveform capture that we've done. So we've got that, we can put all the things in. We can then actually save it on the screen and re-bring it back at any point. Remember, it's very important to save your captions and also to put in the connection of what wire you plugged into, what colour the wires were, what terminal on the sensor you went to. So you can then capture that, save it on the database onto your own laptop, or you can put it onto the waveform library. But like anything, we want good and bad waveforms because people can compare. And as you'll see, the example that we have on the screen now is very much different to the example we gave you. So this is the whole process of learning and looking at waveforms to understand what happens. Okay, we're going to go back to John now.
Thanks, Phil. Yeah, so that is just really making the point that if you think that connections with an oscilloscope are complicated, actually they're no more complicated than working with a multimeter, but what you can see is so much more valuable. And just remember those guided tests are there really to help you through, to help you and get your understanding, you know, not just about how you make the connection, but also point you in the right direction to making good diagnostic decisions based around facts. Like we say, test not guess. Okay, so back to the presentation. So that's just a summary there where we are. So we're just going to jump slightly sideways. When you download our software, you also get another free piece of software called Pico Diagnostics. Pico Diagnostics is a suite of tests that are designed, well, initially they were designed around about battery testing, so engine performance basically. So we have battery tests, we have compression tests, we have cylinder balance. So it's a way of understanding, you know, how a vehicle's operating. So today we're going to do our battery tests, and what I should also say is now our MVH system also is part of Pico Diagnostics, and we're going to come to that right at the end. But today we're going to do a battery test. Firstly, because before we do any diagnostic process, we should check that, you know, we've got a good state of a battery, because that will affect the performance of everything else. So effectively, Picoscope is also a free battery tester. A lot of our vehicle manufacturers use Picoscope as their preferred battery tester, and it really is a very simple connection. So we're going to have two wires. So our first wire on channel A is going to be across the battery, so literally obviously clearly just attached to battery positive, battery negative. And then we've got a 2000 amp current clamp on channel B, and that is away from the positive connection on the battery. So it's just two connections, very, very simple. And then we have a wizard. So the same with any other battery tester, we have to tell the software what the voltage of the battery we're testing is, what type of battery it is, obviously, the temperature, so the ambient temperature that we're working in, and then of course cold clamp amps, so on and so forth. So we've got to give the information to the software, but it runs through a wizard, and once the software is ready, then you have to press start, and then it will tell you to start the engine. And what we're going to then see, and Phil's going to show you this live on the vehicle, we get this this traffic light system. So green being good. If you've got an amber, it might be advisory, so you can advise your customer that there might be a problem coming in the future, something he's looking at. And obviously if you've got a failure, so something in red, it's something that needs immediate action. So yeah, so that's it. Oh, and finally what I should say is that top right hand corner. So you can have a fully customized printout, so you can put your garage name, details, you can put your own logo in. There we've just put a picture of the scope, and that's a printout that you can, that's time and date stamped, that you can give to your customer just to show them that you've operated that test prior to any further analysis on their vehicle. Okay, so over to Phil and also back to bonnet cam, and let's have a look at battery testing with Pico Diagnostics.
Thanks for that, John. We're going to go through the test. So what we're going to do is we're going to just show you the software on the screen. So we're going to go to the software on the screen and we're going to talk exactly. So we've opened up Pico Diagnostics, and the first thing we've got to look at is on the bottom of the screen, you'll see here that it says Picoscope 44258 opened successfully. Now remember, always shut the software down, because with Picoscope you can only run Picoscope or Pico Diagnostics singly. So you need to shut down Picoscope and then go into PD. And again, if you're going to use Picoscope 7 or 6, you need to shut down Diagnostics. So we've done that first. Now we're going to go and show you where the help menu is, how you do the test and what we're going to do. So we've clicked onto battery test and we're now going to go we've got that on there, got that on there. Let's just check that we've got our lead. So, into the help menu. So we're going to go contents. We're going to go tests, battery test, connections. Let's just make the screen bigger. So just like anything else in Picoscope, we've got the screen. So we've got on the screen our positive cable onto the battery, positive and negative. We've got then our current clamp around our starter motor lead. So once we've done that, we're going to shut down the software help file, and we're now going to go to the battery test. So we've got down here voltages. So we've got either 12 volts or 24. So this is actually a 12 volt battery. And on the screen, you'll see we have a drop down menu with lead acid, AGM or calcium. So we're going to pick lead acid. And what I did earlier was I took the temperature of the battery using our thermometer, so we know that this is 21 degrees. So we're going to go and change up to 21, and we also know that the cold cranking amp of the battery is 680, and we're going to put SEE. So we're now going to push the button to start, and John will crank the engine over and we'll look at the test results. So as you can see on the screen, the software calculates the load on whatever we've got on the battery, and is looking at the starter motor, the battery and the alternator. So you're doing 3 tests all in one go. So as we said, look at the condition of the battery. Battery is good but perhaps needs charging. Starter motor resistance, perhaps we need to just check our resistance on there and check our connections, because the vehicle has been standing stationary for quite a long while. But again, as John has said, we can print this out. we can look at the details, and we can zoom into any part of the screen that we need to. We can go into here, draw a square around it, see exactly what we've got. The beauty of PD is it gives you all the results on that A4 sheet of paper. You can save it, print it out, and save it like on any normal waveform. It just comes up with a different logo. This facility is built into all of the Pico software. Thanks, John.
Thanks, Phil. Okay. Yeah, so battery testing, Pico Diagnostics, are really a great added value product from Pico. Okay, so let's move on swiftly to some more component testing. So we're going to do our coil on plug test now. So this is a really useful item within the kit. So our coil on plug probe is designed specifically for picking up signals on single coil packs, but actually you can get a signal from almost any actuator. So we do use it on other things, and if you joined us last year, you saw we were looking at diesel injections with the coil and plug probe. So in terms of how we make the connection, it's just obviously a one channel connection. So we're on channel A with a BNC plus cable, and we're going to locate the top of the coil pack. So the really important thing is when we are placing the wand onto the top of the coil pack, you want it to be really flat. And if you're comparing one coil pack with the next one, you want to make sure you're putting it in the same place on each coil pack. In terms of how we run and gather our data, capture our waveform, we need the engine running and on idle to operate the test, and when we can capture our signals. And this is somewhere we're using those reference waveforms, we can very quickly build up a picture. If we think we've got a faulty coil pack, you can compare it against the other coil packs in cylinder. So one thing I should also say about coil and plug units, so we're talking really today about single coil packs. If you've got one of those big multi-coil packs, they're not so popular nowadays, but do you come across them? They tend to be very well insulated, so you won't be able to use the signal probe, coil and plug probe on that. So in that case, what you'd have to do is take the whole unit off, and then you'd use HT extension leads and connect into the scope. So you can still capture the signal, you just need a different accessory to do so. And then in terms of what we read, one of the real big beauties of back to these guided tests, when you first start capturing waveforms, building up your understanding, you're not going to know what's happening at each stage within this signal, but the guided test is there to help you. So we can see all of the phases. See if I can get my cursor here. So this is, at this moment, what we're seeing here is the coil pack storing energy. So it's storing energy ahead of firing the spark plug. So this is actually firing the spark plug here. And then what we expect to see here is that some coil ringing, all those coil oscillations at the end. So we should see all of those stages if the coil pack is working correctly. And again, the guided tests are there, and these are screenshots I've taken from our guided test. It talks you through the different stages, in this case, with that coil pack firing. So it's about capturing your data and then reading and understanding what's going on within the waveform, and the guided tests will take you quite a way through that. So we have all of these little animations, and they're all on the YouTube channel, so that's YouTube Pico Automotive. And there's a huge amount of data on that because we can really take you inside the diagnostic process. And this just very quickly is going to show you, how we capture our data, but more importantly, how we use those reference waveforms. You remember when I was showing you through Picoscope 7 earlier, how we use a reference waveform. So if we suspect we've got a faulty waveform, so in this I think we have got a problem with cylinder 4. So there's our waveform, so we've captured that good, so the good known waveform from one of our good cylinders, and now we're going to compare what do we see in the faulty one. well, we can see that it's actually not storing any energy. So see the difference in the waveform, and that's often what we're just looking for. We're looking for something that changes. So we've verified we've got a problem. Again, we've changed the component, and using the scope, we've also verified the fix. So we know that the component we put on, you know, and it does sometimes happen, you can have a brand new component comes out of a box, and that might be faulty. So, you know, that can really lead you down a diagnostic rabbit hole. So we'd always say, whenever you've fixed a problem, verify the fix using Pico scope. Okay, let's go and have a look at this live on the vehicle. So back over to you, Phil, to have a look at coil and plug testing.
Thanks, John. So what we've got here is our BNC connector. So we're going to connect this to the scope. We've got our coil on plug probe leaning on top of the coil pack. So we'll plug this into there. Make sure we've got a good connection. And now on the software, we're actually going to go to ignition coil. So we're going to go coil on plug. We've got all of our settings here for distributor or wasted spark or multiple coil packs. So we're going to go. Now we're then going to go millivolt setting, guided tests. So what we've got here is our drop down menu, and I'm stressing millivolts. What you'll see is that on some of our coil packs, depending upon how well they're assembled, you will not get a signal. So this is why we use the millivolt reading and not the old plug kV reading that you're probably familiar with. So we're looking at millivolts, and sometimes you may have to change the setting in the software depending upon how well this unit is assembled. So what we're going to do is just show you the guided test, and there is the little video there explaining what to do, exactly how we've done, and the waveform that we're going to expect to see on the software. So again, we've got here how and what we should test and what we should look at, all of our different bits and pieces. So all the information Sean talked about, further guidance. So we're going to close this down. And here we have our basic setting of our software. So what I'm going to do is start the vehicle up and then push the button on the software. So we're now going to start the software up. Okay, so now it thinks that it's got mismatch probe settings. So what we're going to do is run with the found sensor, and here we have, you can see on the screen where we've got the coil pack, and it is just starting to go. Yeah, now as you'll see there, it could be that it's thinking it's over voltage. So what we will then do is go to 200 millivolts, and you'll see the pattern on the screen. So as you can see from John, it really depends upon where you position the coil on plug probe as to what results you get on the screen. So please make sure that actually this is positioned in the right place, because if it's not, you won't see a signal. So remember, position it in the right place. You may have to adjust up the settings on the software. Okay, now what we're going to do is we're going to stop that. I'll just turn the engine off, and we'll talk about what we've got on the screen. So what you'll see here is the plug. We've got our pages of information here that we can look at and see. So you can see we can go back through all the different waveforms that we've got. We're looking at the firing line here, and what we can do is use our rulers within the software. Put one there and one on there. Now this is actually our burn time on our coil pack. So we're looking to see our burn time. So if someone had dropped the spark plug or the gap had not been set correctly, that is going to affect our burn time on there. So we can see exactly what's happening. If we got a faulty coil pack, that the components inside the coil pack had gone down, like the one that John showed you earlier, you wouldn't see that nice cool ringing and everything in there. So again, remember, save the waveform, capture it, save it on your database, and you can print it out and show the customer exactly what fault you've got. Just remember to plug or to put the coil on plug probe onto the sensor in the right position, otherwise you may not see something. And you may also just have to set the millivolt settings higher or lower. Thanks a lot, guys. Thank you.
Thanks, Phil. That's great. Yeah, and hopefully you could see on bonnet cam there, the real beauty of the coil on plug probe is that it's got that flexible end. So, you know, you probably noticed when I was just putting it on, you can kind of bend it so you can get it nice and flat onto the coil pack. Even if you've got to go under wires or something else, it makes it easy to get into position. And like I said, you can use it actually on injectors. So we do, well, not that this shows injector testing, so this is another one of our animations, but you could do the same job here using a coil on plug probe. But the point actually, in just very quickly looking at how we would capture diesel injection, any form of ignition in a vehicle is relatively easy to analyse, because you've of course got multiples of the same thing on vehicles, so you can compare, you know, very quickly, you know, using those reference waveforms, you can very quickly build up, you know, 2, 3 or even 4 and beyond signals all on one capture. So here we've got our diesel injector, so we've got our 3 phases of ignition, and that's what we'd expect to see. So really a good trick here, something that you'll come across as you start to become a more advanced user, and we can actually hold that pattern on screen. So here we go, so we're going to move, we're doing a snap throttle test here, so this is quite a nice way to see that things are all working correctly. And then again, so like I said, so we're now going to go on back to cylinder 3, and we can just compare the different cylinders against each other. So build up those layers of information and understanding using the scope. The best thing you can do as a new user is actually download the software and just start to run it in demo mode like I did earlier. You know, you can manipulate those waveforms and those demo signals and really start to find your way through the guided test and build up your own understanding. Okay, so we're going to do one more test. Yeah, we should have this very quick test, and then we'll have a break. So we're just going to start to dip into one of our case studies. So we're going to start to now look at a multiple connection. So we've got a fairly common issue. So we've got a cam and crank position correlation issue, P0016 being our fault code. Fairly box standard car, certainly in the UK, so Vauxhall, Opel Astra. So we knew that the car had been to another garage, it had cam belt change, the fault code had come up after that, and actually the garage asked us to go in and see what could be seen with Pico scope. And here we have it. So just to explain to those of you who don't understand what we're looking at here. So we've got our cam sensor. So this is different, like Phil said earlier, you know, hundreds of different cam signals. So getting a good known waveform from the vehicle you're working on can be a real big help. Then this is a crankshaft sensor. For any of you familiar, you'll be fairly familiar here. So what we end up with is There's a gap on the flywheel where the sensor picks up the rotation. Actually, it's picking up all of the teeth as well, and then there's another gap, and then another gap, and this repeats again and again and again. All electronic, or vast majority of electronic components are designed to do the same thing again and again and again. Actually, the way they operate relies on that. So we look in a little bit more detail. So this is just a zoom in. So we've got, there's our gap, but look, we've got an extra gap. What causes that? Well, actually, we've got a missing tooth on the flywheel, and if you think about how that sensor's working every time the flywheel's spinning round, if there's a gap in the flywheel, it's actually effectively seeing 2 gaps every revolution. So it can't be anything. The sensor, and then in turn the ECU, can only assume there's a problem with the correlation. Well, actually, there's nothing really wrong with the correlation, it's just that the flywheel's got that missing tooth, so it's just completely out of sorts. So again, of course, we've got to replace the component. Yeah, and then, of course, you can test it again. But we could see all of this without removing a bolt, so we could see this by just getting to the cam and crank sensor. Crank sensor can be a little bit more difficult to gain access to, but actually if you've got a vehicle up on a ramp, it's normally on the bottom of the engine, so fairly straightforward, back pinning probes. You know, you've made connection within 5 or 10 minutes, depending on how many covers you've come off, but you can see, effectively you can see inside the engine with what's going on. Okay, Philly, you're going to take us, we've got time for, we'll have a quick run through cam and crank on the car.
Yep.
Back over to Phil one more time before break.
Thanks, John, for that. So what we've got on the scope now, we've plugged in another BNC Plus connector, and we're now going to go onto our other sensor. So here we are here, so we've got them 2. So what we're now going to do is we're going to open the software, and we're just going to go, let's put it 50 volts. This is exactly the same sensor that we saw earlier. So what I'm going to do is I'm going to start the software. Well, John shows you what happens. That's the connections that we've got on there. Okay, so initially the software will set itself around. What I'm going to do now is I'm just going to actually separate these 2 channels so you can see what they are. So all we've done, sorry John, can you just, sorry, let me just save that for a sec. Yeah, okay.
The live people, the live.
Right, okay. So, just to prove it is live and we're not all videoed, what we've got here is, we've got our cam sensor and our crank sensor, and we're going to zoom in. So we're going to look at what we've got on the screen, and as you can see, here we have cam and here we have crank, and if you look here you'll see that these 2 lines that we've got that we talked about earlier of being interference are actually on the screen, and you can actually see them in the software. So what's actually happening is, look at our software back on our screen. We zoom into this a little bit more, you'll see that actually that is our ignition system. So the pattern that we've just seen with the coil on plug probe, we can actually pick up. Let's just zoom in again so you can see it. This is actually our ignition patterns. And you'll see ignition is on the screen. So again, you don't actually always, some of the things we see on there, because of the environment we're in, if John shows the camera down here, you'll see we've got our coil packs, we've got our open wiring loom, we've got our connectors connected to our sensors. We're going to pick up interference, be it from the lights, the air conditioning unit, or even actually just the engine. And that's what we're doing now. So don't disregard what we've got. So whatever you see in the pattern, that may be there and we may be able to see things. So
what we should also say is, Phil, so this is our camshaft sensor. Our crankshaft sensor is close under the engine. So we've got a breakout lead. That's purely because we're not lucky to have a ramp. So we just got it here so we can make the connection. But actually, if you're up on a ramp, probably backpinning probe's going to be the best way to go, really.
And again, we're just looking at the characteristics on the screen of what we've got of the two sensors working together. So, you know, that's great. And we're going to go towards a break now.
I think so. I'm going to stick on this camera. Okay, I think we're more or less on time, which is a minor miracle. So we're going to take a break now. We'll come back at 1/2 the hour. And we're going to start off, I think, if my memory serves me correctly, looking at an electric vehicle test. So we're going to start to look at future technologies, how things are going to change. Everything's different, but whilst everything will remain the same. So have a break, grab a cup of tea or something stronger. Seems very tempting. It's been a long winter here in the UK, but the sun's shining tonight. So anyway, we'll see you in 1/4 hour. Thanks for watching.
Thanks.
Welcome back, everyone. A 15-minute break never seems like 15 minutes to me, but hopefully you've had time just to get yourself a little refreshed. Okay, so we're going to move on to some slightly more complicated subjects now. We are limited in the time that we have to kind of cover these subjects, but what we will do in each case is set you some homework. There's more information online, and as we go through each of these case studies, which is effectively where we're headed now, you'll be able to go away and find out more information online. So don't worry too much. And like I said earlier, all of this information, this video, this link will stay up so you can watch it on catch up, go back and recap on anything you may have missed. Okay, so we're going to have a look at a Prius case study. But before we do that, we're just going to have a quick run through the main components on an electric vehicle, because of course everything's changed. The fuel's changed, and the motor's changed. But there's so much about it that has a similarity to what we're all familiar with. So yeah, okay, we're not putting petrol or diesel into the cap, but we are still filling up the battery with electric, and that electric passes through our power delivery module. So it turns it from AC into DC, and then we're filling our battery with power, which of course then, when we need it, we can run back through the inverter and the controller into our electric motor, which of course then goes through our gearbox. So at the moment most EVs are fitted with a single speed gearbox, but it is still a gearbox, and I think what we're going to see in future technologies is certainly 2, maybe more speed gearboxes to get the very most efficiency out of those electric motors. And then of course we're back into components that we really are familiar with. We're still driving the wheels. Maybe on some models we've got electric motors, maybe as much as 1 on each 4 corners, but we're still driving those wheels in the same way. And then around and about that, we've got additional systems that are all 12 volts. We've still got a 12 volt system. It's very, very important that we still analyse, going back to battery testing. That battery is as important on an electric vehicle as it is on current ICE, internal combustion engine vehicles. It's particularly important on a Tesla, because I found out the other day that apparently if the 12 volt battery on the Tesla runs out of power, not only can you not open the whole vehicle, you can't get under the bonnet, there's no way to gain entry without, you have to pull the 2 side panels under the wheel arches off, and then there's these 2 emergency exit kind of things that opens and flips the bonnet up so you can get in to charge up the 12 volt system. So yeah, certainly 12 volt systems on modern electric vehicles are as important, certainly as important. I couldn't claim they were more important, but certainly as important as they are now. So that's just trying to think about, as the world changes, understanding how the main components within EV are and how they all interact with each other. Okay, so back to our case study. And what we try and do for the second half of Pico Academy is look at case studies and just try and go into a little bit more detail. This came from one of our distributors, one of our very gifted distributors, Mickey, in Hungary, who does a lot of work, particularly on hybrid, but also electric vehicles now. So he had a fault on a vehicle, Toyota Prius, and this really harsh vibration in the engine bay, which correlated to engine speed. So on a road test, you'd get up to maybe 40, 50 miles an hour, and suddenly the whole vehicle was shaking. No fault code, so as can often be the case, we've got no fault code to lead us to the cause of the problem. And live data is showing us that everything normal. So clearly there's something wrong, but we've got no way of kind of finding what that problem is. So just to say that before we get into this testing, everything had been tested from a mechanical point of view. So all the wheels have been balanced, all the suspension parts checked. So everything from a mechanical point of view, from a kind of rolling point of view, has been checked and is all okay. I don't know if I mentioned it, but I should mention that the entire case study is now on our YouTube site. It's about 40 minutes long, so I am just going to kind of take you through the stages of Mickey's analysis, but it will give you quite a nice little teaser in to hopefully want to go and watch the full video, so you can gain a real understanding of. So there's Mickey. So this is more about, so we've got no fault code. What's our strategy? You know, so we're going to try at the first instance to do non-intrusive testing. Okay, so this is Mickey's strategy. But the first thing he's going to do is actually before we go into the first thing, I should, as we do with any EV test or hybrid testing, everything, you know, we have to have the correct level of training to work on the vehicle, and we have to, of course, have adequate PPE. I must say that. Sometimes we kind of get hung up on running into the testing, but, you know, as with all EVs, what you'll notice when we're looking at the guided test on EV, you have to click through to confirm that you have adequate training to operate that test, and of course the right PPE. So back to Mickey's test. So actually the first thing he's going to do is just do a frequency analysis on the inverter. So to use this, he's just using the MVH microphone. There's nothing special, we're not removing any component, we just want to listen to see if he can pick up the vibration on the inverter, and more importantly, we're trying to see if the inverter is actually working at the correct frequency, what we'd expect for that. And we are going to come back to frequency. So basically this is Mickey's test. So long story short, 2.5 hertz is more or less as we'd expect to see from that inverter. So the inverter's not leading us to a problem. Just a very quick animation, we do come back to MVH later. But let's just have a quick look at frequency. And frequency is obviously how we hear or indeed feel a vibration, and that's the frequency between the noises. So we're talking about amplitude and loudness of a noise. Now look at how that changes. So we've got those forks. If we hit it with a smaller hammer against a larger hammer, look how things change. And then look against two hammers the same size and long pitchforks against the shorter pitchforks. See how that frequency changes? So what we're looking for in our analysis of the inverter is we want to know if that inverter is running within the frequency we'd expect it to see. And in terms of Mickey's analysis, and he'll talk you through that if you want to look at it, 2.5 hertz is what we expect to see. So we don't think there's a problem there. So now we're going to go into a three-phase current measurement. So we get into the EV side of the vehicle. So in this case, we've got a new EV kit. So you need 3 2000 amp current clamps. And that waveform you see there is taken from our guided test on a three-phase current measurement. So we expect to see all three phases to be even. So we're almost back to our sawtooth. It's completely different. But so what we're expecting to see is all three phases are working in complete correlation with each other. Yeah, because they have to. And this is the actual measurement. So now we're starting to see a problem. So let me just show you through this. So we've got our three phases. So look, we've got 1, 2, and then the third one we see a spike, and then that disrupts the next two until it kind of settles itself down, and then it happens again and again. So the same thing, you know, these electronic components are designed to do the same thing again and again and again. If something changes even on one of the phases, it does disrupt the next two phases. So okay, so we've got no fault code, we've got a three-phase current measurement that clearly isn't what we'd expect it to be. This is textbook, this is what we expect to be. So we've definitely got a problem somewhere within the current. But what can cause it? So Mickey's next view is, well, it's most likely to be the resolver voltage, something in here. So again, we've got a guided test. So you can go into the guided test and look at that. And we're going to see our waveforms across these three sensors. So let's just, and again, this is what we expect to see. So we've got, let's just click this on. So we've got one fixed and then two pulse width, amplitude modulated. So effectively what we'd expect to see is this one. It is still running behind, but they're fixed. Whereas actually with these are amplitude modulated, so you get these kind of waves running through. If you see, this one's running in opposite to that. So this is what we'd expect to see. When Mickey captures it, and in his video he takes you through actually the whole waveform and then drawing in. When we look at these two, notice how they're not consistent. Yeah, so here, I wish my eyes were better than they're not. So we've got that these are the same height. All Mickey does in his videos, you'll see later, he draws one. You know how when Phil was looking at waveforms earlier, you can manipulate them across the screen by putting one, overlaying one on top of the other. We see that we've got a difference in height between these two signals. So again, clearly we've got a problem. What's causing that problem? Well, we're back to what we quite often do, which is a wiggle test. So we try and figure out if there's a wiring issue, so we're wiggling the wires coming in and out. And actually what was quite strange was that Mickey found a problem with one of the connections. So he was doing contact resistance measurements across, and actually the PCM was being fooled into the position of the rotor. So when he actually started to look at the pins in this connection, he noticed one was bent and it just wasn't making the correct connection. So it was kind of connected but not properly. So what it does, it affects that resolver, so it's just not getting the correct power. So actually what we got a really massive issue, felt like it was, something to do with wheel, tyre imbalance, something mechanical, but actually caused by a really tiny fault just in a connector. Probably caused by, this was a 2-3-year-old car, someone had moved the connector, somehow one of those pins had got knocked, and when it got pushed back in, it just wasn't making the correct connection. And there you go. So we've ended up with a huge fault caused by a really tiny component. And only by getting into the detail can you see the fault. So again, it's about capturing data, capturing waveforms from a component in real time. So yes, with electric vehicles, with hybrid, yes, to some degree the ECUs are designed, of course, to spot faults. But what happens when there is no fault caused by the ECU? What's happened if we haven't got a fault code? You're still going to need a technician, which is where you guys come in. You're still going to need a technician to work your way through, a nice structured diagnostic process, checking components one at a time, safely and correctly, and hopefully you'd be able to identify the same fault that Mickey did here, which effectively saved the garage certainly thousands of pounds when we're into electronic components. So like I said, we don't really have time to go into that in the detail that we need to do it justice, but please take the time to go and have a look at Mickey's video. It's on our YouTube site, so it's www.youtube, obviously, and it's Pico Automotive. Cool. And and then back to the guided tests. So they are in there. And one little hack to notice. In some of the guided tests, you'll see there's a link to a video. So what we've got is our technicians in the workshop. So Phil and his colleagues are starting to build up videos of all of our guided tests. So you'll see there's a link in software and it'll open up a video. So we don't kind of just have that flat guided test. We actually have a video which is similar to what we're able to do tonight. So we can connect to the vehicle, we can show you under the bonnet, we can show you the waveform live with the vehicle running, and we can take you right through that diagnostic process of looking at that component. So that's a really good thing to look out for with the new guided tests that are coming in to the new Pico 7 software. Okay, so just a quick recap in terms of understanding waveforms. We've got a lot of information at your fingertips. Guided tests would be the first place to look at. Waveform library, absolutely, have a look. Now that isn't yet available in Pico 7, so you're going to have to be in Pico 6 for the waveform library, but we aren't far away from waveform library in Pico 7. Myself and Phil and our colleagues here, we've now got versions of Pico 7 that we're running. We're doing the first testing. I think you'll start to see a waveform library in beta. Where are we now? Well, nearly end of May. Certainly I would think by the end of next month you may well see a beta Pico 7 with waveform library. But if anyone asks, don't say that I told you. And then of course, technical data, having access to good technical data, absolutely key. Those service bulletins, what I showed you right at the beginning, is there a known fault with the component you're testing? That can save you certainly many minutes, if not hours of time diagnosing a fault if you've got access to good technical and service data. And then of course all the stuff that we do online, like Pico Academy with a huge amount stuff. Join our forum. You're going to need a forum username and password to get on the waveform library anyway. So join the forum, go on there. There's a huge amount of case studies that are really, really valuable. And then finally, of course, training. All of our distributors have access to good face-to-face training. Let's hope we can all get back to some face-to-face activity in the coming months and certainly years. But really using all of those, all of that information you can lay your hands on is going to help you build up your diagnostic understanding and process. Okay, we're going to now move on to pressure testing. So a quick introduction to WPS 500. So this is our pressure transducer. And very simply, it just takes pressure into the pressure port in front of it and it fires out the back end of it a voltage. So we can see the pressure as a waveform, obviously on our waveform, on our Pico software. What can we prove? Well, basically anything, be that air pressure or liquid pressure. So we can look at oil pressure, we can look at fuel pressure, low pressure. We can't do high pressure diesel because of all the caveats around safety. And then of course we can look at in-cylinder compression. Those of you who joined us last time will have seen that in the previous. We're going to do something slightly different today. And exhaust back pressure is a really, really popular one to get a really quick overview and understanding of exhaust back pressure. DPF, so anywhere where there's a pressure in the vehicle we can see it online. Okay, and then we have a range of kits. This is our Maxi kits, is one of our largest WPS kits, but just like the normal Picoscope kits, we've got a range. Again, best place to look is online, so a range of adapters. But tonight we're going to take you over and have a look at an injector back leakage. So this is a test that you'd be fairly familiar with, looking at diesel back leakage with the little bottles. We can do exactly the same test, but working with the pressure transducer. So I'm going to pass you over to our personal king of pressure, Steve Smith, and he's going to take you through one of our newer animations and this test on back leakage. Over to you, Steve.
WPS 500 pressure transducer, looking at diesel pulsation in the spill return line. So this is injector back leakage. Let's run the animation and look at how we'll connect the pressure transducer and the kind of waveform that we'll obtain from a good and a bad vehicle. So here we have the control plunger that lifts, reduces the pressure above the pintle, and of course we get diesel injection. That contributes to pulsations in the spill rail. We have a current clamp on injector number 1 that'll act as our synchronization signal. We switch on the pressure transducer, ensure the test port is open and calibrated. Remove the spill line and place the diesel return back leakage into the pressure transducer. We open the pressure transducer tap there, the drain tap, and we allow that to return to a bottle external so we can measure the volume of fluid that's coming off the back leakage. And then remember, this is for a low pressure return system. So we crank the engine here and we can see the pulsations there in the animation. And we apply a little bit of gas and you'll see that the pulsations increased. And there is our pulsations at idle. Uniformity, once again, is what we're looking for. Now we'll use the zoom feature, start the vehicle again, and we see how that has increased the amplitude. This is using the zoom feature of the pressure transducer. Okay, so let's look at a control plunger that is contaminated. So we're still getting some lift, but we're getting marginal lift, and as a result, we aren't getting the contribution to the spill that we would expect. And there you see it, diesel back leakage. We've got 3 reasonably even pulsations, but certainly something wrong with one of them. Let's have a closer look at the waveform. The final waveform in the animation revealed uneven contribution to spill return to back leakage. So here we have injector number 1. This is the pulsation that arrives in the spill return as a result of opening injector 1. The firing order is 1, 3, 4, 2, so this will be cylinder 3 and this will be the contribution to spill from injector 3. This is number 4, definitely something different here, and then this one will be cylinder 2. So cylinder 4 is not contributing to back leakage as the remaining injectors, the remaining cylinders. So whilst we had the vehicle running on 4 cylinders, this actually is early warning that perhaps we could have an anomaly with injector number 4. Using the WPS pressure transducer to capture diesel back leakage allows for a unique insight into the individual pressure pulsations generated after each injection event, and therefore we can qualify them across different engine speeds.
Okay, good. So that there's a series of videos actually just gone up on our YouTube channel. There's 9 different tests that Steve's done working with the pressure transducer. So I certainly recommend a look for that. And like I said, what we're trying to do in this second half is really to give you a kind of a flavour for the sorts of testing you can do with Pico, and more importantly, where you can use them every day. So yeah, have a look again on our YouTube site, a huge amount of information on there, but some really, really great tests working with pressure against time. Okay, so our final section this evening is looking at NVH. So like I think I said earlier, last year, the biggest request we had from people who were looking for other things, other tests they'd like to see was an introduction to NVH. Now NVH is a massive subject, but what we can do tonight is give you a little flavour, and then we're going to send you off again, like I said, with some homework. So very quickly, what does NVH stand for? Well, noise, clearly, vibration, but more importantly, harshness. The harshness tends to be this really kind of hard knocking sound, something that can be really aggressive, so like an inspection fault. So that's what NVH stands for. We're going to have a quick look. Hopefully you're enjoying all the animations we're showing you tonight. For us, it's a really nice way because we can kind of take you into the vehicle and the analysis. So this is an MVH diagnostic kit. Like I said, a whole range are available. So this is just showing you a very typical road test. So we got 3 channels connected to Pico. So that's each of our axes on our accelerometer is so the forward and backwards, the side to side and the up and down. They're each picked up on a separate channel on the oscilloscope, and then we'd go out and do a road test. So just one thing to think about when we're thinking about MVH, quite often what we call the source component isn't the way that you feel it or hear it as the driver, as the passenger. So often it's the responding component that you feel or you if you feel or you hear it, which is coming for a transfer path. So actually you just need to be aware of that. So, you know, a very simplistic one would be like we've got here. So we might have a source component which could be a tyre vibration, but actually you feel it in the steering wheel. But of course it's not the fault of the steering wheel, the fault is often the tyre. So just we need to understand that we've got source components, we've got a transfer path, so the way in which that is being transmitted through the vehicle and then what you feel as the driver. So the best place we could send you to would be on, again, back to YouTube. So we've got a series of 7 videos. There's the thick end of 3 hours videos here. And you really do need to start at the beginning with these. So you need to go through the theory, you need to understand about the setups and how you work with MVH. But what we're going to do this evening is kind of look at a case study. This is built around a cooling fan imbalance. And I'm actually going to hand you back to Steve Smith. And on this video, Steve was actually working with Frank Massey, and they were working through this case study together and showing you how to do a noise and sound analysis with Picoscope MVH. So I'm going to pass you over to them.
WPS 500. So up until this point we've looked at vibration only. What about noise? What about complaints of noise, cabin whine, whistle? These are all higher frequencies. We've got a case study here that we can replicate. That is what turned out to be a cooling fan issue. But the story goes that minor accident damage, front end of a vehicle. Body repair is perfectly fine, but at certain moments there is quite an intense vibration passing through into the cabin. So this is where, if it's a complaint of noise, then we should include the microphone. We can still use the accelerometer, but let's add the microphone and place that in the cabin, ideally next to the driver's ear, if it is them who is complaining of the noise, or maybe rear view mirror, because that will give us an overview of all the noises present in the cabin during the road test. So let's have a look at this animation. So here then we're adding the microphone to channel D. There we have the issue. This was damaged cooling fan. And here we're displaying the noise in bar graph view. So you can see there we've got the vibration, the intense vibration. That comes on when the cooling fan comes on at top speed. And we're displaying there the bar graph view. On the right hand side you'll see the top 5 unknown vibrations. And that's unknown because it's not linked to engine or road speed. It's an electric cooling fan.
So what I've picked up there from the bar graph, Steve, is that it is an unknown frequency. It's not related to anything that we're able to synchronise from known data from the vehicle setup.
Yeah, that's exactly right, Frank. And the view we've chose there, on the right-hand side, the bar graph view is showing the top 5 unknown vibrations. We've highlighted vibration 1, 39 hertz it is, peak vibration detected by the accelerometer in the vertical axis, but also detected by the microphone inside the cabin. So I think we're certainly tuned into the customer's complaint. Let's go and replicate this on our van. So what we've done here with the van is simulated exactly what you saw in the animation. We've introduced a deliberate imbalance to the cooling fan. We've also then introduced the microphone into the cabin. So not only will we measure the vibration, but we'll measure the sound, which remember is one in the same thing. The microphone and the accelerometer both detect the vibration, the sound generated, and display them differently, but at the same frequency. So we can use either or in this scenario. Certainly this would be your choice of measurement for chasing a transmission whine, for example, or brake squeal, anything sort of above 200 hertz.
So really this technique is for indiscrete noises which really can't be easily identified to a particular component.
Yep. Okay. So connection-wise, we've gone for 3-axis plus single channel. So still use one accelerometer measuring all 3 axes. But the additional channel now, channel D, is the microphone connected to the rear view mirror. So in a road test example, the microphone will detect all noises, but there's a specific noise we're chasing here, which is the noise generated from the imbalance in the cooling fan.
And I guess from this setup, would you also recommend moving the position of the microphone once you're honing in on the noise to perhaps increase the amplitude of the results?
Yeah, the opportunities are endless really, because certainly always keep a microphone in the cabin as a reference, because that's what the customer can hear. Perhaps keep one in the cabin, one in the engine bay, and also keep the accelerometer as well. So you've got 3 points of reference really. Think of bearing noise if you've got the luxury of 4 microphones, 4 accelerometers, 1 road test, 1 measurement with a reference inside the cabin.
Would you also recommend multiple microphones in the same way you would accelerometers?
I would most certainly, yeah. The advantage really of the accelerometers is we lose a lot of the ambient noise. However, the microphone is, gives a real true representation of what the customer can hear. Mm-hmm. So always include a microphone in these kind of measurements as your customer reference, as a kind of an indication, a representation of what the customer can hear. So the setup here for the cooling fan noise vibration, we've gone for a static RPM. Remember, we're not road testing, we're not looking for a vibration relative to engine or road speed. We've gone for a 3-axis plus single channel measurement. 3-axis is our accelerometer mounted to the driver's seat, and the microphone is up at the rear view mirror. That's giving us the customer's audio reference, if you like, what the customer can hear. So if we go to record and analyze, we'll restart the recording because we've got previous data here. There's a warning there to let you know that if you do restart the recording, anything you have here is now lost. We'll start the recording here. We'll use the auto scale feature. And we'll let the software, the scan tool software, run the cooling fan. Okay, if we can stop the cooling fan there, we'll pause the software, and we can then drag our highlighter here, pull that onto the offending area, which is this area here. Use the right-click auto-scale feature, and we can see that both the accelerometer and the microphone have picked up the frequency, the offending vibration noise that the customer can hear. We can just use the channel in view and concentrate on the audio. So channel in view enables us to take away channels A, B and C, which is our accelerometer. And we're left then with this offending frequency, the highest peak in the spectrum. This is approximately 38 hertz, 36 hertz. This is our offending frequency. So
now how can we, Steve, we've got this 38 hertz, how can we then relate that to a specific component?
Right, it's a great question. I mean, we know that that is the peak that we've captured during the vibration, during the noise. We know that frequency and speed are directly related. Hertz times 60 is RPM. Well, we could actually use the speed of the cooling fan, because if we've got one disturbance from this cooling fan, remember in the animation there's a blade missing. On this cooling fan we've added weight. One disturbance per revolution. Let's use an optical pickup on the fan, which theoretically should give us a frequency of about 36, 38 hertz.
So just using an independent, handheld, optical
pickup.
RPM interface.
Yeah, using Picoscope.
Right.
So how have we created the imbalance in the cooling fan here? Well, simulating what you saw in the animation, a missing blade, we've placed a bolt through this blade here. So for one revolution of the fan, that will create one disturbance. How can we determine the speed frequency of this fan? Remember, speed and frequency one in the same. We attach some silver tape here and point the optical pickup at the cooling fan. So every time the optical tape passes the optical pickup, it generates one pulse per revolution. That will give us the frequency of the fan. We can then use Picoscope to not only count those pulses but display the frequency of those pulses, which should come out around about 36 hertz, because that's what we captured our vibration, our peak amplitude vibration at 36 hertz in MVH. So using the optical pickup to determine the frequency of the cooling fan, we'll connect that into channel A of Picoscope, run the cooling fan at the top speed, there is only one speed setting for this one, and see what Picoscope displays in terms of frequency. As you'll see there, I've actually placed a marker signal ruler at 36 hertz, so Picoscope is frequency coupled. And theoretically, if we've got our maths right, when we run the cooling fan, we'll see that top speed or peak vibration occurs at 36 hertz. Could you run that, please? Okay, if we switch the cooling fan off now, if we just pause the software at that point, we can see how the frequency climbed as the speed of the fan increased and topped out approximately 36 hertz. If we do the maths on that, 36 times by 60, the cooling fan 2,160 RPM. So another way, Frank, of qualifying the frequency speed of a component.
Sure. It may be worth mentioning also that your channel input command has been set not from AC DC but to frequency to obtain this information.
Yeah, the frequency coupling of Picoscope, so that's available in the current 4000 and previous 4000 generation of Picoscope.
I think the really interesting thing I've picked up from this bar graph is that we can clearly see on the right hand side that this frequency of around 35 hertz sits quite nicely between E1, E2, so we know it's not the engine. And I think the way I'm thinking at the moment is, if we increase the frequency of the engine, there could be a situation where we get resonance, where we get two forces out of balance which add together. But looking at it in this way, we're able to separate this issue and see very clearly that this is a non-engine related component causing this problem.
So we had concentrated on the frequency view. This is exactly the same data, no different, but in bar graph view, where we've used the software to highlight the known vibrations on the left and the top 5 unknown on the right. In this scenario, we had 39 hertz. Remember, cooling fan frequency would be dependent on battery voltage as well. So if we are going to run the cooling fan for simulation, battery voltage is key for RPM. So that concludes the introduction of microphone in this presentation. Join us in the final presentation where we'll look at a number of real-life case studies where we've used a combination of the accelerometer and the microphone to determine the cause of customer complaints of vibration and noise.
Hi guys, right, what we're going to do is we're going to show you the setup that we've got on. So we're going to go to the screen in Pico Diagnostics and just explain to you what we've got. So on the screen here, we've got our little menus that we have to fill out. So we've actually got our J2534 lead plugged into our diagnostic socket. and it's plugged into our laptop. John's just going to show you the diagnostic socket. Yep. Okay. So we've then got, on this particular occasion, we've actually gone to multiple sensors. So we've got one interface with the 3 leads plugged onto the accelerometer. So there we are. We've got our accelerometer on the seat base down there. And then on the second box, we've got the microphone attached to the headrest. So as you can see on the screen that we've got on my screen, you'll see exactly what we've got on the screen with the software. So now we're going to show you some of the menus that we have to populate on the screen. So on the software, we have to go vehicle information. So it's front wheel drive, rear wheel drive, all wheel drive or 4-wheel drive. So we picked front wheel drive. We then had to put in the tyre size. And then what we've actually done in the advanced settings is we've actually put in the gearbox ratios. Now, if we go back to our main camera, what I've had to do is go on to the Volkswagen website, and I've had to pay my €5. So I know that my gearbox code is that, and it gives me all of my ratios, which I can then put into that box from this bit of paper. Now this isn't going to be available on normal standard data information like Autodata. You're going to have to go onto a VM site to get this. The more information you put in the software, the better results you get. So then on the screen we go apply changes, and then we go and do our road test exactly the same as Steve has done. And we look at our results and we can then see what's happening. So again, it's all about putting the correct data in and seeing what's going on. And you'll see from what we did before, that's just a very brief description of how we set the scope up, how we set the interface boxes up with the microphones and the accelerometers. And not forgetting, we need the road speed for the vehicle to understand how fast it's going. Thanks, guys. Thank you.
Thanks, Phil, and Steve and Frank. Yeah, great. So, yeah, just a reminder that, those videos are on our YouTube site under the playlist NVH, so noise, vibration and harshness. So really, if you're interested in that subject, and there's the final video, which may sound a little bit perverse, but actually if you started in the final video where they go through the case studies, you'll start to understand where you would apply NVH to everyday diagnostic problems, faults. So you might find it useful to start with the final video and then go back to the beginning, because you really are going to need to understand the theory of NVH to get the very best out of it. But you might find starting at the last video gives you the reason why you need to start to understand about noise, vibration, harshness issues, because it's much bigger than, you know, just tyre and kind of suspension vibrations. You can really see faults within an engine almost before they occur, and actually one of Frank Massey's really clever case studies shows you that and how you would see that with NVH. Okay, so that's a kind of very quick whistle-stop tour of 3 really quite big subjects. So just to kind of tidy up this evening, bit about Team Pico help and support. So a reminder of our website address, so www.picoauto.com, make sure you end up there, and obviously the YouTube site. There's our contact details for head office here in the UK. What we'd always say, you know, you've been invited along by our distributors tonight, so please, you know, in the first instance, contact them, because often they'll have the answers that you need. But you ever need anything, you know, we of course back that up from head office in the UK. Also remember about our automotive forum, create a username and password, go on there. There's a huge amount of information in there, particularly around diagnostic problems and faults. So I really would strongly advise, become a member of the forum and start to work your way around there. And then finally, a message from Pico Planet. So this is a division within the business which is aiming to push our environmental concerns and make this, try and turn our business into a zero carbon business. This came out of looking at the IPCC report in 2018, which is, science basically showing us that we really have a massive program and challenge to stop the world going above the 1.5 degrees that was agreed back in 2015 with the Paris Accord, and with the world seeing, and even since we started Pico Planet 2 years ago, how far the world has changed, not just with COVID, but of course some of these really serious world events around hurricanes, forest fires and droughts. These are all effectively what we're seeing as products of climate change. So within a business, what can we do? We're just one business in a million businesses, but actually we decided that even within the automotive industry, we want to make some really positive changes. So we have. So we will aim to be carbon neutral by the end of 2022. So effectively it's only 18 months away. We are massively reducing business flights. Well, COVID kind of gave us that anyway, but even prior to COVID, there will be a much reduced business flight program. A lot of what we can do online, similar to this evening. In terms of the building where we are today, so we're in the workshop, but in our main building, we're having that super insulated, so we're not using as much energy as we were. And then there's a big program that we're just starting now in terms of cutting the waste in our production and in the packaging. So when Phil showed you through our kit earlier, my heart sinks because we still have a lot of plastic packaging in our product, and that's something that we really want to work to change. So there's a lot to do. There's a lot for all of us to do, but I think we all need to do it. So we need to start to take some of this stuff really seriously. If you are interested, and I think anybody with children or grandchildren really should be, I thoroughly recommend this book by David Wallace Wells. It's a really stark read, but one that we really ought to start to take on board. Okay, I know there's a lot going on. Are there any questions on YouTube? There wasn't anything earlier. Still nothing. Okay. Well, hopefully you've got all the answers. We've answered all the questions before they came, but if you get anything, we'll be on chat for a little while. So if you think of anything, let us know. But for now, from me and Phil, we'd just like to say thanks for joining us this evening, Pico Academy, and we will continue to do these sessions, so then there'll be another set of sessions that we'll be running in the autumn where we're looking for some new. We'll be doing more EV testing, so we've just taken delivery of a full EV Golf, so we're now able to do some EV testing in the workshop, so that'll be coming in the new year. As also we plan to go do something a little different. We're going to go on location and do some off-highway work with our WPS 600. So lots more to come. Pico Academy will get bigger, but again, if you've got thoughts and ideas of things you'd like us to see, case studies you'd like us to cover, drop them a line. That's why we ended up, covering NVH this time. But anyway, for now, thanks for joining us, and until next time, see you soon.
Cheers, bye.
Good night.